All right, so we're going to do a reaction of baking soda and vinegar. We're doing 12 parts vinegar, which is acetic acid, and we're doing 1 part baking soda, which is sodium bicarbonate. Excuse my dog. So the reaction here is acetic acid, that's the vinegar, and we have sodium bicarbonate, which is our baking soda. And the reaction is going to create sodium acetate with carbon dioxide and water. And so I just want to introduce conservation of mass. That is telling us that mass cannot be created or destroyed. So when we look at the reaction, we're going to notice some things happening with the mass and changes in it. But here we can really understand conservation of mass. We see that we have 1 sodium before the reaction right here, and that after the reaction we also just have 1 sodium. It didn't go anywhere and we didn't create any additional sodiums. So then hydrogen, we can count how many we have here. 1, 2, 3, 4, 5. So we have 5 before the reaction. And we have the same amount of hydrogen after. 1, 2, 3, because of the subscript. 4, 5. So we have 5 after. So how many carbons and how many oxygens do we have before and after the reaction? Are they conserved? And we can count them out and see that we have 3 carbons before and after. 1, 2, and then this one, 3. And then 1, 2, 3 for the carbon. And then for oxygen, we're going to have 5 and 5. So we can see that the mass is conserved, but it's going to look different when we watch it because it's changing from solid and liquid to gas. So whenever we add this, we're going to see it fizz as it has a reaction, and then we're going to see that the gas that we're creating, that carbon dioxide, is heavier than the air around it, so it can sink down and essentially be poured off of the reaction, and it's going to come down and put out these flames and deprive the flame of the oxygen, so it's going to snuff it out. Okay. Do we want to keep going with the dog sounds? Yeah, let's just keep going. Okay. So we see it fizzing as it's reacting. Oh boy. And then I'm not pouring any liquid to put out these flames. I'm pouring off the gas. And there's a certain point where we can see that it's not putting out the flames anymore. So why do you think that's happening? That's because the reaction is not creating the same amount of carbon dioxide anymore, and so it's not able to pour off and put out these flames. Yeah? Also, just like we're talking about conservation of mass with these candles, as we burn them over time, we actually see less of the candle because a lot of the candle, including the wax, is leaving as a gas. And so a cool thing about that is that whenever the gas is burned off and the wax is in that smoke, then you can actually relight the smoke to relight the flame of the candle. So it should reignite from the smoke. So we can just light the smoke up here and it shows up and lights